Woohoo! Welcome back. Tonight we're going to be talking about logarithmic functions. Woohoo! Now, what is a logarithmic function, you ask? Well, I'm so glad you asked. We're going to let a be a positive number, but not equal to 1. So that's where we're going to start off. And the logarithmic function with base a, denoted by log with a little tiny a in a subscript like that, is defined by log base a of x equals y corresponds with a raised to the yth power equals x. Now, I imagine the first time or the 12th time or maybe even the 100th time you see this is not going to make as much sense as you'd like it to. But we're going to get to examples down here, and hopefully by then it will make sense. But let's just talk about a few things first. So a few things to talk about. Log base a of x equals y is pronounced log base a of x equals y. So you may want to practice that. And there are two special logarithms that we talk about. The first one is log base 10, because 10 fingers and thumbs. And so log base 10 of x is just written without a base. You just have to know it's base 10, and that's known as the common log. And then log base e of x is actually natural log of x. And that's the natural log, and that's based on base e. Woohoo. Okay, so let's get going. Convert to logarithmic form. Now, if I'm asking you to convert to logarithmic form, it means that we probably have exponential form. Exponential form is exponents. Woohoo. So I've got 2 cubed equals 8, which is true. Now, how do I write that in logarithmic form? This is what you do. You start by giving yourself a log for logarithmic form, and then you go to the base. Remember that the base is the number which is being raised to a power. So here, in this case, the base is 2. So you write that down low. This is log base 2. Now, you don't write 3 next. You write the answer next. Log base 2 of 8 equals 3. And this gives us some insight into what a logarithm is. Because the logarithm is asking you, okay, if we're in 2 land, tell me how many 2's there are in 8. And we don't mean like multiplied, we mean like exponents. So 2 raised to what power gives me 8? And in fact, it's 3. It's 2 times 2 times 2. So this is what a logarithm does. A logarithm looks into a number and tells you how many of a given base has to be multiplied together to give you that number. Okay, so then what if it's something where it's a little bit less clear what's going on? E squared equals x. So if it's e squared equals x, we don't necessarily have as strong a connection with it in the way that 2 cubed equals 8 is probably something you already knew. So we're just going to have to use the pattern that we set here, or if you want the pattern that was up there, we're going to start with the number that's the base. And I'm going to write log base e, and then I'm going to go over to the answer of x. How many e's are there in x multiplied together? And the answer is 2. And then I notice that, in fact, log base e is one of the special logs. And so I'm going to write it as natural log of x equals 2. And I wrote the L as a fancy L because otherwise it looks like a 1 or an I. And then people think it's in, when in fact it's lin, natural log or log natural. Okay, again, I've got an exponential expression. 10 raised to the negative first power is 1/10. And that corresponds to log base 10, go across to the answer of 0.1. So how many tens multiplied together give us 0.1? It's kind of a weird question. The answer is it's actually 1 over 10th. 1 over 10, or 1/10. So the log base 10 of 0.1 is -1. And again, this is one of our special logarithms. So I've got just common log of 0.1 equals -1. I don't have to write in a base. It's assumed to be 10. Woohoo! Nicely going so far. One page down. Woohoo! A lifetime of learning to go. So next page. Dun dun dun. Now, if we already have logarithmic form, how do we know we're in logarithmic form? Well, you see the word log, or you see this natural log. So you see a bunch of logs, and I want you to convert to exponential form. So if I have log base 4 of 16 equals 2, remember that, what does that mean? How many 4s multiplied together in 16? And the answer is, if I take 4, so I always start with the base, and then I go across to the answer, and I square it, that gives me 16. Woohoo! Okay, now log of y equals 5, we're missing information. If I just have logarithm, but no base, that's log base 10 of y equals 5. So remember that I start with the base, I go across to the answer, 10 to the 5th equals y, or y equals 10 to the 5th, which is, let's see, there are 5 zeros, 100,000. So that's pretty cool. Okay, next one. Oops. Come back, squirrel. I just figured squirrel could join us because squirrels know a lot about logs. So, natural log. This one I have to remember to write as a logarithm. Log base e of e equals 1. Now, that might look a little bit confusing, but let's think about what a logarithm does. It counts. How many e's in e? Well, just 1. E to the first power gives me e. So again, start with the base, go across to the 1, and come back here. E to the first power equals e. Woohoo! Nicely done. Yay! So let's do a couple of problems. What if I have log, just log, so common log of 1,000 equals x? So the first thing I'm going to do is fill in the blanks here, specifically that I've got log base 10 of 1,000. Okay, now if I am in logarithm form, I will be able to, and you will be able to later on in this chapter, deal with this directly, but right now our best bet is to convert. If I'm in logarithmic form, I'm going to go to exponential form. I start with the base, I go across, 10 to the x power equals 1,000. So what is that power? And I'm reminded that 1,000 is 10 cubed, which tells me that x equals 3. So this is, I took it from logarithmic form, I wrote it in exponential form, and then I had to remember how many 10s multiplied together gives me 1,000. And the answer is 3. Okay, let's do another one. Log base something of 9 is 2. Now you may already have a good idea about this one, but let's go ahead and convert to exponential form. Start with the base, that's x. Go across, x squared is 9. Now, x squared is 9, there are two answers, right? Either x equals -3 or x equals 3. Now, if you recall, and this was kind of quick, so you may not remember, but right in the beginning I said let's let a, which is the base, always be greater than 0. So in fact, the base has to be greater than 0, so that can't be an answer. So our answer is, look at me loving the answer x equals 3. Yeah, my squirrel friend likes it too. Woohoo! Okay, so let's keep going. I've got one more problem I want to do for this part of the video. Dun, dun, dun! Oh no! This is exciting. Look at how exciting this is. Log base 12 of the quantity x minus 1. Now you see how I've put parentheses in? Because this is a much more interesting, complicated, complex argument for the logarithm. So I want to make sure that I include all of it. You can always put parentheses around your arguments for logarithms. Some people leave them out. As you've noticed, I've been leaving them out when I've got a simple expression like log of 1,000 or log base 10 of 1,000. I tend to leave the parentheses out. Some people like to put them in. So it's really, it's a matter of taste and I guess good training perhaps. So again, if I have a logarithm, generally for right now, I'm going to use exponential form to see what's going on. So exponential form says I start with the base, 12. And I say 12 to the power 1. So there's 1 12 in this thing, gives me x minus 1. Okay, so what's 12 to the first power? That's just 12. And that's got to be x minus 1. So what is x? So if x equals 13, if I plug that in, 13 minus 1 is 12, and then it asks log base 12 of 12 equals 1. Is that true? And the answer is yes. How many 12s are there in 12? Just the 1. Woohoo! Okay, so that's the first video. For this section, I have one more video coming, I believe. I think it'll just be one, maybe two. And so make sure you have your calculators for the next one. And make sure that you know that I think you're amazing and awesome and incredible. And, take a break. Go look at something green or rest your eyes. Go do something fun. Move a little bit and then come back and join us for part 2 of this very exciting video series on logarithms. Woohoo!